Okay, let's make a start. So, hello everybody. Welcome to this webinar, wherever you are, whatever time it is in your part of the world. The main presentation today will be given by Dr. Mike Nicholas of the UK's Environment Agency and backed up by Dr. Tim Fox of the IMechE. My name's Richard Hallebrand. I'll be hosting the team's event. I'm a mechanical engineer. I've worked in the process industry, high hazard industries for about 40 years, including asset integrity, projects, energy management and process safety. As well as hosting it, I'll introduce the speakers, tracking questions from the Q&A and the chat so that Mike and Tim can answer them at the end. Just before I get into that, a little bit of housekeeping. The event is being recorded. It will be put on YouTube in the IMechE's Process Industries Division playlist. You'll see the link for that in a minute. We have disabled attendees media because we don't want interruptions, so it makes it smoother. If you attend for long enough through this, you'll get a CPD certificate, whether you want one or not. It's fairly automatic. Please submit your questions in the Q&A or the chat. We'll try and keep an eye on both of them. And Tim and Mike will talk about those at the end. Slides will also be made available as a PDF when we've finished this all. If I spot any AI chatbots, I will kick them out. You have to pay attention, not get the chatbot to keep an eye on it for you. So that's just me. Right. Just if you're not from IMechE, Process Industry Division, we've got various industry focuses. I'm not going to go through all this in great detail. Look us up on LinkedIn. You'll find that we do quite a lot of things, organise quite a lot of events, lectures, seminars, and even conferences. And we're quite representative to government and international bodies, particularly promoting education, training, and CPD. We also value people, whatever their background, sexual orientation, colour, don't care. We're all engineers. It's for everyone. We want people to feel included. We've got policies about that, but they're not just written down policies. We really mean it. If you want to get involved, contact us. Happy to get you involved. And then I'm just going to hand over now to, I think, Tim, who's chairing it, and Tim can introduce himself and Mike and head on towards the slides.
Thank you, Richard. And also welcome to all of you from me to this webinar. This is the first in a new series of webinars organised through a collaboration between the Institution of Chemical Engineers and the Institution of Mechanical Engineers. And my name is Dr. Tim Fox, as Richard has said, and I'm a past chair of the IMechE's Process Industries Division, and I'm currently chair of the IMechE Climate Change Adaptation Working Group. And I'm absolutely delighted to be the chair of this inaugural event today. Just a couple of words of background before I introduce Mike. I think many of us are probably aware as practicing engineers that we're living in a world where much of our industrial plant was, and indeed often is still, designed and operated based on the past climate conditions. Now, the issue is that, as we're increasingly aware, we're now experiencing greater threats, more frequent threats, and higher risks from climate change. Essentially, in short, we need to ensure the safety of our people, our equipment, plants and machines, and we need to build resilience to these more frequent and more severe extreme weather events. And also indeed to a range of other climate impacts that are slower but continuous. So the background changes to the climate causes, such as increased length of droughts and severity of droughts, etc. So, but not only do we need to do this, we know that as an industry, we need to do this while simultaneously continuing to increase our efficiency, reduce our greenhouse gas emissions, and deliver financial returns to our stakeholders. And fundamentally, we underpin economic and societal well-being, not just for nations as a whole and broader regions, but the local communities across the globe that rely on our industries for their employment and their community well-being. So, in this new webinar series, our two engineering institutions have come together to jointly explore this issue in detail and depth, focusing specifically on the adaptation needs of industry and increasing its resilience to climate shocks. And in this webinar, which is the first of the series, Mike Nicholas, who's an industrial adaptation expert at the Environment Agency, is going to be providing us with an overview of the challenges faced, not only by the industry, but the challenges faced by us as an engineering profession. Mike is indeed a chemical engineer and a climate change adaptation and process safety expert, and he's employed at the EA. But in addition to the EA, he is a committee member of IChemE's Environment and Clean Technology Specialist Interest Group, as well as the EA representative on the Process Safety Management Competence Board, the Chemical and Downstream Oil Industry Forum, and the COMAR Strategy Forum. Now, I've known Mike for a number of years. We got involved together around this issue of adaptation and building resilience. And Mike champions the embedding of climate and environmental risk adaptation into management systems, as well as developing regulatory expectations and guidance for the UK's high hazard industries. He's clearly eminently well placed to provide us with such an overview, and I'm delighted to ask Mike now to take the floor. Over to you now, Mike.
Thank you very much for that introduction, Tim. I will just start sharing my slides now. I think as the slides are loading up, hopefully you can see them. It's well worth reflecting, and I reflect on this, how climate change is impacting all of our roles. I've been fortunate enough to work across different functions at the Environment Agency, and whether it's the work the Environment Agency does in England to maintain our flood defences, create the flood and coastal erosion risk management strategy for the nation, whether it's the way we regulate and help operators to comply with their environmental duties, whether it's the advice we give to government. Time and time again, we see the threats of climate change are impacting on all that we do at the Environment Agency. So as I'm talking to you, it's very much from an informed position of we're dealing with this as well. We're needing to adapt, as well as looking to industry businesses to build resilience at the same time. So as Tim mentioned, I'm going to give an introduction to climate change adaptation, really as the kickoff to a series of webinars, and we will look in future webinars at many different aspects of adaptation in greater depth. But for now, I will cover the basics. What is climate change, and how can climate impacts affect process industries and critical national infrastructure? And then what can engineers start to do to manage the risks that climate change is posing? And I'll conclude by looking at what's next for the webinar series. Indeed, Tim, I think you've got some information on some wider activities going on within the institutions. So if we start thinking about what is climate change, very familiar term, but in terms of scientific terms, the definition that climate change refers to large-scale, long-term shift in the planet's weather patterns and average temperatures. And people talk about the global climate in terms of the global average temperatures. We can also talk in terms of local and regional climates, in terms of the long-term average weather patterns that a local area may see at country level, for example, or even subdivisions within countries. Whatever level of resolution you're talking about, there is agreement internationally, and that is that the climate has changed, and the climate is going to continue to change. And it's unequivocal that human activities have warmed the planet. The emissions of fossil fuels and other greenhouse gases are causing a rise in the overall mean temperatures that we are seeing. So basically, greenhouse gases are causing global warming, which is changing the climate. And there is a wealth of evidence which supports that change has happened, and scientific projections that it will continue to happen. If you look at the globe picture there from NASA, it's quite apparent also that there is not uniform change around the globe. In terms of mean temperatures, the poles are heating more rapidly to a greater extent. And that is of concern for us all, because the poles is where a lot of water is currently locked up in terms of ice caps. And the ice caps that are on land masses, such as the Greenland ice cap or the Antarctic ice cap, when that ice melts, it will cause sea level rise. It is already causing sea level rise, but it will continue to cause sea level rise, and that will affect all coastal communities globally. So there are regional variations, but it is an issue of global concern. And when we talk about climate change, there are two key sides: climate change mitigation versus climate change adaptation. And it's really important to understand the difference between the two, and the fact that both go hand in hand, and you need both mitigation and adaptation. So in the industrial context, industrial climate mitigation is the term used for combating the root causes of climate change, reducing emissions of greenhouse gases, whether that's CO2 or methane, for example, driving down those emissions, sometimes referred to as the transition to net zero, which involves shifting to renewable energy, also other measures improving energy efficiency. On the other hand, there's industrial climate adaptation. And the school of thinking goes there that however fast we mitigate, we already have locked in a degree of temperature rise with the global average temperatures and associated changing climate impacts. So whatever we do with mitigation, we also need to adapt. We need to enhance resilience of everything we do, to rising temperatures, to increasing storminess, for example, rising sea levels. And there are also other aspects that we need to consider. The water sector, managing water resources, agriculture, the ability to grow crops and the types of crops that can be grown. So whilst this graphic looks at industrial climate adaptation, it's clear that it's a whole of society issue. And indeed, industry relies on many other sectors which are equally vulnerable to climate change, and there might be cascading impacts throughout our systems. It's also worth noting that the net zero solutions we're looking for mitigation absolutely need to be resilient to future climate impacts, whether that be strong winds, which can lift solar panels, lightning, which can set wind turbines alight. As engineers, we have a definitive role to play in looking at the external weather and other climate impact threats and making our future net zero solutions resilient to what is going to come. So how much climate change are we going to see? This infographic is taken from a tool which we have developed within the Environment Agency, and this tool is available publicly on the internet if you search Climate Impacts Tool. We developed this tool to help all of our staff think about the present day situation and also possible future scenarios when they're making decisions either at strategic policy levels or indeed when thinking about individual projects and plans, to enable them to build climate impacts into their thinking and decisions. So the science is unequivocal. At point 1 is roughly where we are in the timeline. So when you look to present day conditions, evidence around the world shows that the climate has already changed. We've already seen warming approaching 1.5 degrees compared to pre-industrial levels. And I'm sure you're all familiar with global news stories, repeatedly seeing intensifying wildfires, impacting flooding. You can't miss the intensity increase and the frequency increase that we are now seeing of extreme weather events and other climate impacts. The warming that we've already seen is just the start of a continued warming that's projected to happen into the future. This graphic shows the potential increases through to 2100. We already have a degree of warming locked in, so that by 2050 we are likely to see a 2 degrees C increase globally. Now, if we get our skates on and make a swift managed transition to a low carbon net zero economy at a global scale, we may be able to limit global warming at about the 2 degrees rise compared to pre-industrial levels. Unfortunately, global policies are not in that position, and we're looking at nearer 3 degrees or slightly above with implementation of existing policies. And there is some uncertainty with that. Will we actually achieve implementation of the planned policies, or will there be some unforeseen feedback loops where actually the climate might warm more rapidly? It is foreseeable that in those cases we could see 4 degrees C warming or even more by the end of the century. Now, that warming is on a global level. Data is available extensively, regional and local variations. And a good place to start is the work by University of Reading. Ed Hawkins has created the now famous climate stripes, and they colour code the increase in temperatures. So the slide here I've got is taken from the Show Your Stripes website, and it selects the temperature change in England from pre-industrial period through to present day. Very clearly shows how the trend in English average temperature has increased. And if you look on the scale on the left hand side, we've actually got a minus 1.5 through to a plus 1.5. So whilst global temperatures have increased by 1.5 degrees, actually England and Europe is warming at a faster rate than that global average. And at the Environment Agency, back to the Climate Impacts Tool, we've produced guidance for our staff on what that actually means, because it's not just about increasing temperatures. That increase in temperatures puts extra energy into our climate systems, and it changes weather patterns, and it changes them differently for different seasons. So In summer, we are already experiencing and will continue to experience warmer and drier summers. Winters in England will become warmer and wetter. We've already seen sea level rise, and the rate of sea level rise is expected to increase. Our summer hot days will get hotter more frequently, and peak rainfall intensity is getting heavier and will continue to get heavier. And that is leading to more extreme flows in our rivers. Peak high level river flows increasing and seasonal low flows decreasing. Much more extreme flows. That is the data for England. Aware that we've got a global audience today, you should be able to source local climate impact data wherever you are in the world. There is an extensive body of science for that. You can start by doing your own research. I pulled up this table by asking AI for sources of national data, and it instantly told me which government bodies, which authorities in which different countries can provide climate data, what kind of data they provide. But the degree to which you need to extract climate data very much depends on the decisions you're trying to make. The degree of accuracy you need, the resolution of that data. So you may be in a multinational company which has its own team of climate scientists. We're fortunate in the Environment Agency to have a group of scientists who pull together the information and do their own research. I know that exists in many multinational companies now. If you're in a smaller company thinking about this, you may need to reach out to consultants. Several consultancies operate at regional level and help support this type of work. Or you could ask your regulator. At the Environment Agency, we do expect operators to embed adaptation into their management systems. But along with that expectation, we also provide guidance and advice on what we expect and where the data can be found. So there are a lot of conversations to be had when you start out thinking about climate impacts on your work. And those conversations will lead you to a wide range of influencing factors. Once you start thinking about the intricacy of weather systems and other climate impacts, geophysical impacts, you find that there are so many different linkages and dependencies that almost every activity can be impacted in some way. And again, within our climate impacts tool, the advice note that we give to our staff, we start to draw out some of those examples. For example, storms and floods can impact emergency responder activities. And the Environment Agency is a Category 1 responder in England, and we respond to incidents. But if the roads are flooded, we physically can't get to those incidents. Or potentially worse, if our head office floods or our control centres flood, that might impact our functions. Similarly, heat and drought can impact industrial cooling systems and agriculture. They can also impact staff well-being. So there's a wide range of discussions and thinking that needs to go on when you're thinking about the wider impacts of climate change on whatever activity the organisation is carrying out. Now, the purpose of this presentation really is to bring us around to thinking about industrial resilience. And one of the recently developed concepts is that of NHATEC, natural hazard triggering technological accidents. And NHATECs are one of the more severe and serious ends of climate impacts. They're the safety and environmental protection linked aspects of climate change. And if you look back over the past 30 years, there are a series of very well-known accidents that have occurred. And as you talk about those accidents and think about climate change, you can see why increasing concern around management of narthex might now be high up on the engineering community's agenda. So if we look back to 1994, a tragic event in Dronca in Egypt, there was a relatively serious thunderstorm, described at roughly a 1 in 70 year event, so not hugely unusual, but it caused storm waters to cascade down off the surrounding hills towards the town of Dronca. On the way, it swept through a fuel terminal and caused a loss of containment of the fuel that was being stored in large storage tanks, and that fuel was ignited by lightning and caused running pool fires to travel through the streets of Dronca. And that caused over 460 fatalities as whole families were trapped in their homes with fire raging through the streets and burning the buildings. An absolutely tragic event, which undoubtedly it could become higher risk as we see the risk of flooding and storminess increasing if we as engineers fail to recognise that increasing risk and fail to put in place measures to manage that risk. Other events, the Great East Japan earthquake caused much loss and destruction up and down the coast, including Fukushima nuclear incident and much more. And whilst the initiating cause was an earthquake, you can foresee with rising sea levels the impact of tsunamis increasing unless, again, there is strategic thinking put into the implications of rising sea levels and the location of industrial facilities and how they are defended. Coming into more recent times, in the Arctic Circle, we've seen a diesel spill in Norilsk, Russia, and that was caused by a combination of aging plant, but also melting permafrost, which caused a failure of a diesel storage tank and a spill of diesel into the local river system. And there the cleanup costs are reported to be in the order of $2 billion. And then locally, back to the UK, we suffered an extraordinary heat wave in 2022, where temperatures were jumping 5-6 degrees higher than we'd ever experienced in the past. And we had a number of industrial incidents triggered by that extreme heat, including waste chemicals, flammable chemicals, catching light and waste storage areas burning, pressurized gas cylinders overpressurizing and exploding, and then many wide area impacts with power loss, data center impacts. So the impact on utilities and communications, which all impacted the functioning of industry in the UK. So there's a wide range of climate impacts which can increase risks across operations. It's not just a safety and environmental protection matter. So, for example, high ambient temperatures can impact industrial plant and cooling systems. So whether that is decreasing the ability of cooling systems to reach intended cooling loads, through to the overall operating efficiencies of the entire establishment. High temperatures can affect the reliability of sites, affect staff well-being, and also impact on environmental protection outcomes. If the cooling system in place is to allow cooling water to be discharged to a local ecosystem at a set temperature. If that cooling system is not able to cope with the increasing ambient temperatures, then maybe operations at the plant would need to stop because there could well be environmental limits on the allowable temperature discharge into the environment. And if those are exceeded, there could be quite substantial harm to local ecosystems. So there are a large number of climate impacts that operators need to consider and to think about across the range of their operations. Fortunately, over the last 5 to 10 years, the global standards communities, global engineering communities have been working on this to create standardized ways of managing risk. And this all follows the same familiar pattern that we use to manage any risk, whether it's safety, whether it's finance, whether it's environmental protection or quality. It's all based around the cyclical plan, do, check, act continual improvement cycle that's familiar within all management systems. So starting with a senior management commitment that the organization needs to recognize the increase in temperatures and the change in environment, through to an organization specific risk assessment, and then enacting the measures needed to control the changes in risks, checking that those measures are working, auditing and reviewing, evaluating the success of the measures, and then acting to continually improve where it's found that the system's not delivering. In 2024, ISO amended all their management system standards so that there was a specific explicit focus put on climate change and ensuring that whether it was a quality management system, safety, environment management system, organizations now need to risk assess whether climate impacts will influence the outcomes of that system. So if you ask yourself, if you've got a health and safety management system and you ask yourself, could extreme heat impact my staff safety and well-being? Mostly people would answer yes. Then you need to carry forward that threat into the remainder of the management system and assess, okay, well, what's the risk and what are the measures we need to take to control that risk? In terms of the engineering community, it's been recognised that engineering standards are generally based on designing infrastructure to past climates. And there is a lot of work ongoing at the moment to ensure that engineering standards are updated to present day and indeed become future-proof for future climates. It's not just the global shared standards that we need to think about. It would also include any internal standards which organisations have of their own corporate policies. And on the right-hand side, you can see a guidance note from Senelec, which is intended to give guidance to the standards communities, to any committee which oversees an engineering standard. It advises how they can screen that standard for climate risk relevance, and then how to go about thinking of modifying that standard. Now, if you're in an engineering department within an organisation, you can equally pick up that guidance and apply it to your own internal standards to think whether your internal standards are vulnerable to the changes, whether they're falling out of date. So in terms of the climate resilience challenge, what can we do as an engineering community? Well, it helps if you break this up into two stages of thinking. So on the basis that the climate has already changed, you can ask yourself, do you know if you're safe and resilient today? So part of that process is looking at your own internal procedures. have your hazard identification and evaluation procedures already captured the various natural causes which are being influenced by climate change? And do those external threats, have they been found to impact corporate outcomes? Does your management of change procedure recognise that it's not just people, plant and process which can change, but also the external and natural hazards which also need to be monitored for change? The NARTEC major accidents that I put up a slide earlier, those were just a few of the various NARTECs which are recorded in the process safety literature. Have you as an organisation learnt the lessons from previous NARTECs and considered that whilst an incident has happened somewhere else in the world, the climate has changed so much that it could now readily happen at your site, but you've never thought about that before? Or even worse, does climate change mean you're already operating outside design limits or beyond the envelope of safe operation? Do you even know the answer to that? It's a question you might never have asked yourself. The next stage is thinking about, will you remain safe and resilient tomorrow? So have you got available local and regional climate impact projections, which you can then compare with design assumptions, operating assumptions, to see how sensitive those operations are to the projected future changes? Do these provide new knowledge on threats to compliance, whether it's the ability to control and maintain safety and prevent accidents, the ability to comply with environmental permits, or even other corporate objectives, finance objectives, the expected efficiencies and performance of plant, which can be eroded by various different climate impacts? And I mentioned earlier, have the corporate design codes that you rely on to maintain and design new assets against, have they been reviewed? Are they sensitive to climate change? And should you actually be changing the way you design and think about the operations of your sites? And all of this applies whether we're talking about current infrastructure and the processes we know today, but there's also an opportunity to ensure that net zero processes are climate resilient, that they're located in areas which are less vulnerable to future climate impacts, and that we build in resilience from the outset. So there are many stakeholders which can ask an organisation to think about their climate risks, whether that's people like the Environment Agency, regulators who regulate safety and environmental protection. It could be insurers, it could be investors, it could be your local community, and in fact it could be our children and our children's children, the future generations. What did we do as an engineering community to make sure that the processes of today remain safe into the future? And to meet the challenge that we're facing, there are many different guidances being produced. If you are an engineer in the United Kingdom, hopefully you're familiar with the CDOIF guidance, Chemical and Downstream Oil Industries Forum guidance. Very useful starting point, which goes through the process of managing climate risks, from ensuring top leadership through to how you risk assess, and then how you embed the understanding of those risks into the management of safety and environmental protection. Got the link on that slide, but all of these bits of guidance you can readily find by an internet search. In terms of other guidance, again, the Environment Agency in England has put out guidance on risk assessment and adaptation planning within management systems. And we've also published industry sector examples sector-specific examples of climate impacts on the different operations within different sectors. They're on Gov.uk. The middle part of this slide shows a competent authority delivery guide. That's the guidance that the COMA regulators, HSE, Environment Agency, National Resources Wales and Scottish Environmental Protection Agency, we all use this guidance to help our inspectors know what to look for when they're going out and inspecting high hazard sites. We publish this guidance so that as operators you can see what we're expecting and you can get ahead of the curve. And then of course there's the guidance that's put out by professional bodies like IMechE, IChemE and various other trade associations. And generally there are a few core bits of guidance like the CDOIF guideline which will signpost out to all of these. So in summary, the climate has changed and how can engineers adapt? That was my opening slide and the topic of this. Well, the key points: do you understand how climate impacts are affecting your work outcomes? Whatever your job role is, do you know how they're impacting those outcomes today and the resilience of those outcomes, how those outcomes will be maintained into the future? If you're aware that climate change will change weather and other geohazards, are you managing the risks that change is bringing? Are you embedding climate change adaptation approaches into your work to ensure climate resilience? And if you don't know what good adaptation management looks like, you can start to find out more through the guidelines, but also watch this space. Look out for the future webinars in this webinar series. And with that, I'd just like to flag the next in the webinar series. So IMechE and IChemE are alternating the hosting of these webinars, and the next webinar in the series will look at managing climate risk and adaptation using high resolution modelling. The details are on that slide, and I believe Richard is going to post in the chat the URL. But future webinars,
already done it.
That's brilliant. Thank you, Richard. Future webinars we've got lined up look more detail at how to assess climate risks. Regulators will come and give their views on climate change and their expectations, and then we'll be looking at engineering and management standards in a bit more detail, and some work that's been doing to support the upskilling of UK PLC in terms of developing what good training in the area of adaptation might look like. So a lot of rich material to come, I think. Over to you, Tim.
Thank you, Mike. That was an excellent overview of so many different aspects of climate adaptation and resilience building, with that really strong focus on high hazard industries. I mean, that was really very valuable. Thank you, and I'm sure the audience appreciated that as a good start to the webinar series. So we've got a bit of time left now for some questions and answers with those that are online. Just before we dive into some of those, I've just got a couple of follow-on questions for you, Mike, picking up on some of the themes you brought out in the presentation. One of the burning questions I have is really to understand from you what has been the response of industry to date to what the Environment Agency is doing on embedding adaptation into management systems. How has it been received, and what's success looking like into over the next few years?
It's been received very well, actually, Tim, because as we've seen from our successive conversations with individual managers at operational site level up to boards, I think everyone recognises that climate change is already having impacts and will continue to increase the threats for safety and environmental protection. But there is a skills gap, if you like. There's a lack of understanding within the engineering community broadly on how you go about managing those risks. So the fact that the UK competent authority as a regulator has taken this up as a strategic priority focus for our regulation means that we are prioritizing our resource to share our experience and support those operators on their adaptation journey. We have a shared dialogue going on where we inform them of the guidance that is available. We ask them to look at that guidance, but then we listen. We say, okay, so how's that going? How's implementation going? And there are feedback mechanisms to strategic groups that we have in the high hazard community, which can then fix problems that arise. So we have COMA Strategic Forum in the UK, which looks at the strategic networking and sharing across sectors, sharing learning across sectors. And it was identified, I've mentioned the skills issue, it was identified that was an issue for the engineering community. So one of the fixes we've already put in place is through Cogent supported work, a method by which we can all agree what good adaptation training looks like. So it will produce a standard which training providers can then work to ensure that they are building the skills necessary in a consistent way. So it's all about shared learning and dialogue in the UK and by having the regulatory focus there, the compliance focus there, we keep that on the board agenda so that boards will be able to commit the resource which engineering managers then desperately need to tackle the issue.
Yeah, I'm very interested that you immediately brought up the issue of skills training and a skills deficit in understanding adaptation, and that's certainly been a concern of the IMechE and how we address that. More broadly within the wider education system, how do you think we can go about addressing the issue and preparing graduates from at university level and those graduating from further education institutions to how can we prepare them better for understanding climate impacts and climate adaptation?
I think it's climate change is an issue which is becoming embedded into the education system, but needs to ensure that reflects both sides of climate change, not just mitigation and the need to re-engineer our future to a net zero future, but the adaptation side as well. That if we end up putting our solar panels on rooftops, yes, that's fixing mitigation, but we're going to see increasing wind speeds. So those solar panels then risk being ripped off and being a trajectory and punching a chemical storage tank. Yes. And causing a major accident. So the key thing is talking about climate change from both perspectives and recognizing that it's about resilience engineering at the end of the day, being able to foresight what is coming, and the engineers need to think outside of the people, process, plant box. It's not just about what's happening on your site, but thinking about the threats external to the site and that those threats are increasing. And it's all part of the multifaceted decision process that engineers manage to come to a complete engineering solution.
Yeah, that makes a lot of sense, Mike. And I certainly like your emphasis on ensuring that when educators address climate change, they address mitigation and adaptation hand in hand, and there's so much understanding of net zero and low carbon futures that the adaptation dimension needs to be more deeply embedded in that. But just moving to some questions from the audience, and I do encourage you within the audience, if you do have questions for Mike, or indeed myself or Richard, then please do pop them in the chat, and we can pick those up. One question we've had is from Tom Greenhill, and he says that he works in building design in the UK, where climate adaptation is lagging, especially in existing homes, and we know the issues to do with the existing stock. He's asking really which industries are furthest ahead in your experience on adaptation to climate threats, and what can we learn from them to shift decision makers in slower sectors? Do you have any comments on that?
Yes. So in around about 2008, the UK enacted the Climate Change Act, which was and still is globally leading in terms of climate action. Climate Change Act is quite famously known for committing to net zero, but there's another section of the Climate Change Act which placed requirements on certain sectors of industry to assess their climate vulnerabilities and report back to government on those vulnerabilities. It's known as the adaptation reporting power. And DEFRA, the Department of Environment, Food and Rural Affairs, publishes the reports from those sectors. Now that is mainly covering transport sectors, power, water, so the critical national infrastructure. And if you again search up adaptation reporting power, fourth round, we're on the fourth round of reports, you can find the reports from all the operators who work in those sectors, along with reports from regulators, like ourselves, Office for Nuclear Regulation. And they're generally the sectors which are leading, because they've been encouraged over the past nearly 2 decades to grapple with adaptation management and embed adaptation into their management systems. So there's an awful lot to learn there, a rich amount of material on how to go about the adaptation process, but also really good practical examples of how to adapt, how to make infrastructure more resilient.
Okay, well, look, thank you for that. That's really helpful to sort of lay out where we can find that information. One other question around information and where we can find information is coming from Arthur Scott Bowden, who's asked, what's the most reliable way to stay up to date with the latest revisions and updates to industrial standards related to weather data used in structural and infrastructure design? Are there specific alerts, places we can go, mailing lists that we can be put on? Is there any recommendations you have for how people can keep up with that?
Yeah, so the first thing is, wherever you are in the world, find out who your national authority is, who's responsible for climate data. Again, in the UK, that's the UK Met Office, and the Met Office leads with maintaining scientific knowledge on climate projections and the regional impacts that changing climate will have on the UK. And that's all under the banner of UKCP, UK Climate Projections. And 2018 was the last time they were overhauled in a major sense. But when you log on to the Met Office website, you will see that they are continually expanding the set of data. They provide news bulletins on what new data is. They provide training on an overview of the data, and that data led by the Met Office, by the way, includes other authority data. So the Environment Agency flood forecasting is linked into that Met Office pool of data as well. So once you've found your lead national authority, it's quite easy to find out what the current availability is and sign up to their newsletters. Some like the Met Office now have bespoke tailored services for industry, where you can sign up to receive specific information. It depends on your needs.
Yeah. Okay, thanks,
can
Mike.
I just throw in as well, Tim, that if you're in industry and you have an insurance company, many of the global insurance companies have their own data as well, and they're often more pessimistic because they ultimately end up paying the bills for some of these disasters. So they're very good sources of information. I just it's 4 minutes to go as well, Tim. So we can roll on for a few minutes longer. That doesn't matter. But I think we have got a few closing slides, although I can see there's another question there as well. So perhaps you want to get that one done first.
Yeah, thanks, Richard. Yeah, actually, we've got a question here from Julian Etienne, who's saying it's still rare for those adaptation discussions to mention adaptation limits. That is the point at which we cannot cope anymore, whatever the resources are that we throw at it. And basically, the question is asking, this potentially can cause overconfidence. What do you think, Mike? I mean, should we be a bit more specific about where the limits might lie in adaptation?
Yeah, I think most definitely. And that is actually starting to crop up. We've noticed discussions with industry, certainly across Europe. Certain companies with multiple sites across Europe have come to the point where they are deciding which sites they will continue operations at and which might be closing soon because they can't be defended from rising floodwaters any longer. So we are noticing those strategic decisions coming in. I think also for those of you in England, you might have noticed the way that the Environment Agency talks about managing flood risk has evolved, and the fact that we cannot keep defending specific locations means that there are going to need in the future be community decisions on where we need to have a managed retreat strategy. So again, is it feasible to continue to defend certain locations? There are limits on how high you can build flood walls,
Yes.
and how much you want to spend. So again, this comes back to the boardroom decisions, the risk appetite of the company, understanding that climate change is increasing costs, it is increasing risks, and on what limits is the board placing on that?
Yeah, thank you for that, Mike. I have certainly noticed the approach of the Environment Agency over the last few years in terms of being realistic around what potentially can be protected in terms of flood defenses, and that has come into the conversation certainly most strongly within the last couple of years. So that's good to see, and hopefully that goes some way to answering the question. Richard, I'm conscious that we need to start closing now. Could I have the slide on the next set of slides?
You can. I'll share the slide on some events that are coming up. So this one in particular, the links are already in the chat for what I'm showing, so you can just talk over them, I think.
Yeah, so I'll just introduce this one, and then I'm going to hand back to you, Richard. And so yeah, one thing to make you aware of. Mike has already flagged up the next webinar in this series, and hopefully if you found this engaging and useful, you'll be inclined to sign up for more in the series, so look out for those. But next week in London, if you want to take the conversation further and learn more and engage more deeply, we have the IMechE Second International Conference on Climate Change Adaptation and Resilience taking place at the IMechE headquarters at One Bird Cage Walk, London. on Tuesday and Wednesday of next week. Richard has put the link in the chat. And there's still time to sign up if you're interested and want to register. So yeah, I encourage you to do so. It's not too late. And I'd like to finish my part in this webinar by saying a big thank you to Mike for giving us such a wide-ranging and interesting overview of the topic and where we're going to go with the topic in future webinars. And I'm going to hand back to Richard, who's going to formally close the event. Richard.
Thanks, Timmy. I just add my congratulations as well. And it's certainly, when I heard Mike do something similar recently, it sort of switched me on to things that I wasn't aware of. That's not the only thing related to climate change going on. IMechE, and I'm sure IChemE are the same, but IMechE have quite a bunch of webinars, lessons and barriers in moving to circular economy, sustainability, climate change. There's a whole bunch of things. There's a QR code there you can actually trust, but a URL as well. If you miss it, don't worry, it'll be on the YouTube recording. This one is coming up. And it's very soon. Again, it's next week, even though it might clash with the conference, but most of us can't afford to go to conferences in London, so this is a bit cheaper because it's free. But if you miss it, don't worry, you can catch it up afterwards. Very topical, cleaning up our rivers. That's coming up as well, just a couple of weeks later. And then even, again, it's all topical, the climate change, measuring methane in agriculture. So you don't need to pay too much attention to where these are. I'll leave this slide up because we'd like feedback, please. There's a bunch of things you can feedback on this event, things that you might want in the future as well. No problem with that. Certainly in IMechE, we share all our webinars. We do them for nothing. They're volunteers. We think there's some important health and safety information we need to share around. So we look forward to some more of those in the future. And I put these, some of the links anyway in the chat. So I'm sure you'll figure them out. If you've got any questions, my email's in the chat as well. Follow up and I'll feed them through or get other people involved and we'll see where we go from there. So Mike, any last words from you?
There have been a few questions in the chat about the leading sectors, so I will put a link to the
actually, I mean, you're all right. If you want
there.
5 minutes more, you can carry on talking and answering. It's not a problem. That hour is nominal. I know a few people will leave, but at least they might then be in the recording after. So if you want to carry on, do so.
Yeah. Okay. So probably highlight nuclear sector is leading in this space, but also other sectors such as transport infrastructure is getting a hammering, and there have been lots of work focusing on building resilience in transport. So yeah, I will put the details of where you can find out more information on the adaptation reporting power in the chat.
Just if you don't get sometimes the chat closes when I stop the recording. So if that's the case, then we'll make that available. Anyway, there you go. Anything? I mean, there's been one or two other related questions, but I think they've sort of been rounded up in the general discussions. I think that most people are looking for where do we go next? How do we find out? Where is source of information? We'll just tune into the next webinar, I think, and hopefully we'll flesh out even some of the things that maybe weren't answered today. We can give some answers properly in the next webinars. Yeah, and thanks, Mike. He's put the link in there. And I think if there's nothing else, I think we have to keep to an hour more or less. Most people have got day jobs. In that case, I'm going to end the event. Thanks, Mike, again.
Thank you.
And hopefully we'll see you all again very soon indeed.
Thanks. Bye all.